It's a well-known fact, long periods without rain in desert regions create serious challenges for farming and raising livestock. Farmers there are raising rabbits, millions of rabbits, and these rabbits bring in huge amounts of money.
In the heart of northern China, a battle is being waged against one of the most relentless forces of nature, desertification. The Kubuqi Desert, a vast expanse of shifting sands covering over 18,600 square kilometers in Inner Mongolia, has long threatened villages, farmland, and livelihoods, advancing at a pace that once seemed unstoppable. But in a move that sounded almost fantastical, China released 1 million rabbits into the desert, and what happened next shocked the world. This daring strategy became a cornerstone of the nation's Great Green Wall initiative. Today, we'll walk through it. Let's get started. Where and why? Stretching across the northern reaches of China in Inner Mongolia's Ordos Plateau, the Kubuqi Desert is a stark symbol of both environmental fragility and human resilience. Covering approximately 18,600 square kilometers, an area roughly the size of Kuwait, it is the 7th largest desert in China and a critical part of the Ordos Desert system, which also includes the Muos Desert to the south. Flanked by the Hitao Plain in the north and the Les Plateau to the south, Kubuki occupies a geographical position that makes it both vulnerable to desert expansion and vital to northern China's ecological stability. Historically, this region was once a thriving grassland supporting pastoral and agricultural livelihoods, but centuries of deforestation, overgrazing, and climate variability transformed it into what locals grimly called a sea of death. The transformation of fertile steppe into shifting dunes threatened not only the land itself, but also the economic survival and cultural continuity of the communities that once depended on it. Studies by China's Ministry of Natural Resources and various environmental agencies have shown that over 27% of China's total land area is affected by desertification, with regions like Kubuki contributing significantly to this national crisis. According to data published in Frontiers in Environmental Science, the total area of wind erosion-affected land in China has reached approximately 1.6 million square kilometers. This is around 16.7% of the nation's total territory. The Kubuqi Desert's share of this problem is particularly acute because its proximity to populated and economically active regions amplifies its social and environmental impact. The ecological damage has had measurable economic and human costs. For decades, the desert's advance swallowed roads, farmlands, and settlements, displacing communities and forcing mass migrations. Agricultural productivity plummeted as once fertile soils turned to sand, while wind-borne dust storms originating in the Ordos Plateau traveled hundreds of kilometers eastward, blanketing cities such as Beijing and Tianjin. The economic losses from desertification across northern China are staggering, estimated by China's State Forestry and Grassland Administration to exceed tens of billions of yuan annually due to reduced agricultural yields, infrastructure damage, and public health costs associated with airborne particulates. In the Kubuqi Desert alone, local herding and farming families saw their incomes collapse through the 1970s and 1980s as the desert consumed their pastures and wells dried up. The dangers of the Kubuqi Desert extend far beyond its immediate borders. The desert's location makes it one of the principal sources of sandstorms that affect large parts of northern and northeastern China. During peak years, such as in 1993 and 2001, satellite data recorded extensive dust plumes originating in Kubuki that reached across the Yellow River Basin and into the Korean Peninsula and Japan. These storms not only reduce air quality, but also accelerate soil loss in adjacent agricultural zones, compounding the cycle of land degradation. The United Nations Convention to Combat Desertification has identified Kubuki as a critical node in East Asia's desertification belt. where local environmental mismanagement can trigger regional-scale consequences. The root causes of Kubuki's environmental decline are both natural and anthropogenic. Centuries of unsustainable land use, particularly overgrazing by livestock, unregulated logging for fuel and construction, and the conversion of grasslands into cropland, gradually stripped the land of its vegetative cover. Once the protective root systems of grasses were destroyed, strong westerly winds characteristic of the Ordos Plateau lifted the exposed topsoil, initiating a feedback loop of erosion and further degradation. Climatic factors, including reduced rainfall and prolonged droughts since the mid-20th century, exacerbated the crisis. The Ordos region, where Kubuki lies, receives an average annual precipitation of only about 250 millimeters, while evaporation rates can exceed 2,000 millimeters. This imbalance accelerates desiccation and inhibits natural regrowth. By the late 20th century, the consequences had become catastrophic. Satellite imagery and ground surveys from the 1980s revealed that Kubuki was expanding by more than 10 square kilometers per year. Entire villages were engulfed by encroaching dunes, and transportation networks, including sections of the provincial highway system, were periodically buried under sand. Local government reports estimated that nearly 1 million people across Inner Mongolia were directly affected by desert expansion, losing arable land and access to freshwater sources. The dust storms originating in Kubuki became so intense that they contributed significantly to the so-called yellow dust phenomenon affecting East Asia each spring. China's response to these mounting dangers was shaped by both ecological necessity and national strategy. Beginning in the late 1970s, the government launched the 3 North Shelter Forest Program, commonly known as the Great Green Wall, an ambitious effort to create a 4,500-kilometer barrier of trees and vegetation stretching across the country's northern frontier. The Kubuki Desert became one of the central focal points of this initiative because of its proximity to major population centers and its symbolic value as a testbed for ecological restoration. In 1988, the Elion Resources Group, a private enterprise based in Inner Mongolia, partnered with the Chinese government to spearhead localized reclamation projects in Kubuki. Before large-scale intervention began, conditions in Kubuki were dire. Less than 3% of the area supported vegetation, and the local microclimate was characterized by extreme temperature fluctuations, daytime highs exceeding 40 degrees Celsius in summer and sub-zero temperatures in winter. Wind speeds routinely surpassed 20 meters per second, powerful enough to reshape dunes and obliterate any fragile seedlings that managed to sprout. Groundwater levels were declining, and salinization further restricted plant growth. The region's biodiversity had collapsed, leaving behind a sparse ecosystem dominated by xerophytic shrubs and pioneer grasses clinging to survival. The urgency of the situation was reflected by data collected during the early years of the reclamation program. According to surveys conducted by the Chinese Academy of Sciences, the desert had already expanded into the fertile Hetao irrigation area, threatening one of China's major agricultural belts. Annual sand deposition rates in nearby river valleys were rising, clogging irrigation systems and accelerating siltation in the Yellow River. The linkage between the health of Kubuki's ecosystem and the stability of China's broader environmental network became impossible to ignore. This drove China's commitment to reclaiming the Kubuki Desert. But how? The rabbit reclamation strategy. In the late 20th century, the Chinese government, in partnership with environmental scientists and private sector leaders such as the Elion Resources Group, launched a series of reclamation projects aimed at reversing the desert's expansion. Among these was a bold idea that initially drew skepticism even within scientific circles: the introduction of over 1 million French Rex rabbits to catalyze ecological recovery. The French Rex rabbit, originally bred in France in the early 20th century, is a domestic variant of the European wild rabbit. it is best known for its dense, velvety fur, calm temperament, and adaptability to diverse environments. While domesticated, the rex shares key ecological behaviors with its wild relatives, including burrowing, grazing, and prolific reproduction under favorable conditions. These traits made it a promising candidate for controlled ecological introduction in semi-arid landscapes. The species thrives in temperate regions with moderate vegetation and loose, sandy or loamy soils, conditions that, once stabilized through other measures, could be replicated in sections of the Kubuqi Desert. Ecologists working on the project argued that these rabbits could play a role similar to that of burrowing mammals in other dry ecosystems. They could help loosen compacted soils, enhance aeration, and stimulate microbial activity essential for plant growth. In its naturalized form, the European rabbit is a keystone species in Mediterranean ecosystems, where its burrowing activity creates microhabitats used by numerous insects, reptiles, and small mammals. Its grazing patterns help maintain plant diversity by preventing dominant weeds or shrubs from overrunning grass species. The Kubuki strategy sought to replicate this ecological balance. French rex rabbits were introduced not as free-ranging herds, but through phased, monitored releases across selected test zones. Each release area was chosen based on a combination of soil composition, moisture availability, and existing vegetation cover. The rabbits' population density was calculated to ensure they would graze selectively on invasive or non-native plants, without completely stripping the land of ground cover. This delicate balance was essential to prevent overgrazing, a mistake that had historically exacerbated desertification in other parts of Inner Mongolia. The implementation of this strategy required close coordination between several key stakeholders. The Elion Resources Group, which had already been leading reforestation and soil stabilization efforts since 1988, collaborated with the Chinese Academy of Sciences and local environmental bureaus to design and monitor the rabbit integration phase. Ecologists and zoologists established controlled breeding centers near the desert's periphery, particularly in the Dalad Bana region of the Ordos administrative area, where conditions were most favorable for gradual ecological introduction. The French rex population was initially imported in small batches, with subsequent breeding conducted locally to adapt the rabbits to the arid climate and high diurnal temperature variations of Kubuki. The program's design emphasized the integration of biological and technological interventions. Before any rabbit release occurred, pilot zones were partially stabilized through the planting of drought-resistant shrubs such as saxel and sand willow. These pioneer plants reduced surface wind velocity and anchored the topsoil, creating microhabitats capable of supporting small animal populations. Once vegetation cover reached a threshold of approximately 20%, rabbits were introduced in small cohorts. Each cohort was monitored for survival rates, grazing impact, and soil disturbance patterns. The rabbits' ecological function was threefold. First, their selective grazing targeted invasive weed species, which often inhibit the establishment of more beneficial perennial vegetation. Second, their burrowing activity improved soil aeration and water infiltration, processes essential for root establishment and microbial regeneration. Studies conducted by project scientists from the Inner Mongolia Agricultural University reported an average increase of 15 to 20% in soil permeability within rabbit-active zones after 1 year. Third, the rabbits' droppings contributed organic matter and nutrients, particularly nitrogen and phosphorus, which are scarce in arid soils. Over time, these nutrient inputs helped transform the upper soil layers from sterile sand into loamy, biologically active substrate capable of supporting sustained plant growth. To support the rabbits' survival, supplementary measures were introduced. Solar-powered water stations were installed throughout release areas to provide minimal but consistent hydration, mimicking natural oases. Wind-blocking fences constructed from locally sourced reed mats and biodegradable mesh reduced the direct impact of sandstorms, preventing both erosion and burrow collapse. Local herders and farmers were trained to maintain balance in the new ecosystem, ensuring that rabbit populations remained within ecological limits. The rabbit strategy was never implemented in isolation, but as part of a broader suite of reclamation technologies that defined China's modern desert restoration model. Surrounding the rabbit introduction zones were expanses of newly planted forests, often referred to as green corridors, composed of poplars, willows, and drought-tolerant grasses. Solar-powered irrigation systems, pioneered by Elion in the 2000s, allowed the maintenance of these plantations without depleting underground aquifers. The rabbits contributed indirectly to these vegetative efforts by stabilizing soil between tree belts, reducing the spread of mobile dunes, and preventing secondary desertification. By the time the program reached maturity in the mid-2010s, measurable ecological and economic changes were evident. Measuring the impact. The ecological restoration of the Kubuqi Desert in Inner Mongolia is today recognized as one of the most successful examples of landscape-scale rehabilitation in modern environmental history. Once known as China's Sea of Death, this 18,600 square kilometer expanse of sand has been transformed through decades of coordinated scientific, governmental, and community-led action. Since restoration efforts began in earnest in 1988, more than 6,250 square kilometers, one-third of the desert, have been reclaimed. What makes Kubuki's recovery particularly remarkable is not just the scale of transformation, but the sophistication of its methods, a strategic blend of ecological science, renewable energy innovation, and grassroots stewardship that has reshaped one of Asia's harshest environments into a living, productive landscape. The introduction of approximately 1.2 million French Rex rabbits served multiple ecological purposes simultaneously. Their controlled grazing reduced the spread of invasive weeds, which had outcompeted native flora across vast stretches of the desert. Their constant movement and burrowing helped loosen compacted soil layers, improving porosity and enabling better water absorption and root penetration, critical processes in an environment where annual rainfall averages barely 250 millimeters. Equally important, their droppings enriched the impoverished sandy soil with organic matter and nitrogen compounds, fostering the microbial activity needed to sustain long-term plant growth. Elion Resources Group, the private environmental enterprise that has spearheaded Kubuki's restoration for over 3 decades, worked closely with national ministries and local herding communities to implement a triangular recovery model, using animals, plants, and renewable technology as interdependent tools of restoration. Millions of drought-resistant shrubs and trees, including sand willow, saxaul, and white poplar, were planted in carefully designed grid patterns to anchor the dunes. These plantations were shielded by wind-blocking fences that cut surface wind speeds by as much as 60%, sharply reducing sand movement and preventing erosion. Solar-powered drip irrigation systems were installed to sustain new vegetation using minimal water resources. By 2017, the desert hosted more than 100 square kilometers of photovoltaic arrays that not only powered irrigation pumps, but also generated clean electricity for nearby settlements and industries. These solar installations had a dual ecological role. The panels provided shade that lowered ground temperatures and slowed evaporation, while their placement over planted plots reduced wind turbulence, allowing delicate seedlings to establish. Satellite monitoring by China's Ministry of Ecology and Environment has confirmed that in areas where rabbits, vegetation belts, and solar grids coexist, land surface temperatures have decreased by up to 0.7 degrees Celsius over the past decade, an indication of localized climate stabilization. The measurable ecological impacts of these combined efforts have been extraordinary. Vegetation coverage across the Kubuki region rose from less than 3% in 1988 to more than 33% by 2017, a tenfold increase in less than 40 years. Soil organic carbon levels in restored zones have risen by 25 to 30%, while sand fixation rates have improved dramatically, reducing the number of severe sandstorms that once regularly swept into Beijing, Tianjin, and other northern cities. The National Forestry and Grassland Administration reported that wind erosion intensity in Inner Mongolia declined by more than 20% between 2000 and 2020, much of it attributed to stabilization achieved in the Kubuqi and Mu'us deserts. Biodiversity indicators provide further evidence of recovery. Ecologists have documented the return of over 70 native plant species alongside the reappearance of small mammals, reptiles, and pollinators that had vanished for decades. Micro-habitats created by the rabbits' burrows and the newly established vegetation have enabled insect populations to rebound, which in turn support higher trophic levels of the desert's emerging food web. The reintroduction of kestrels, steppe eagles, and other predatory birds has provided natural population control for the rabbits. Ecological balance can now be maintained without human interference. The environmental improvements have produced substantial socioeconomic benefits for the local population of roughly 100,000 people who live along the desert's fringes. Stable soil and vegetation cover have allowed farmers to reclaim previously abandoned land for cultivating hardy crops such as millet, wolfberry, and licorice root, the latter of which has become a key medicinal export. According to local government data, average annual household income in the Kubuki region increased from less than 600 yuan in the late 1980s to over 20,000 yuan by 2018, a direct reflection of diversified livelihoods derived from sustainable agriculture, renewable energy, and ecotourism. The renewable energy sector has become a cornerstone of this new economy. Photovoltaic power plants, often built in conjunction with restored green belts, now generate hundreds of megawatts of electricity annually, supplying clean power to thousands of homes while reducing carbon emissions by an estimated 1.5 million tons per year. The PV sand control model, developed in Kubuki, is now being replicated in other desert regions such as the Tenga and Badain Jaran deserts. This integration of ecological restoration with green energy development has positioned Kubuki as a prototype for what China's Ministry of Ecology and Environment calls a solar agro-ecological economy. Tourism has also flourished in the transformed landscape. The Kubuki International Desert Forum, first convened in 2007 under the auspices of the United Nations Environment Programme and China's State Council, has turned the region into a global hub for discussions on sustainable land management. The once hostile desert now attracts hundreds of thousands of visitors annually, drawn by the striking contrast between golden dunes and green corridors. Eco-lodges and desert botanical parks provide employment for local residents and educational platforms for visitors, while reinforcing environmental awareness. Perhaps most importantly, the success of the Kubuki project has contributed to a measurable decline in regional dust storms. Meteorological data show that the frequency of severe sandstorms affecting northern China has decreased by over 40% since 2000, thanks largely to vegetation stabilization in desert margins like Kubuki. This reduction has improved air quality and reduced respiratory health issues across major urban centers. Local climate moderation has also been observed. Humidity levels have increased slightly and wind erosion has slowed, preventing further encroachment of desert edges into agricultural zones. The Kubuki model has since been incorporated into global sustainability frameworks. UNEP, the United Nations Convention to Combat Desertification, and the World Bank have all cited it as one of the most successful examples of nature-based solutions for arid zone rehabilitation. The project's deliberate blending of biological agents like the French Rex rabbits with renewable energy infrastructure and human-led reforestation has redefined what is possible in ecosystem management. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.